Famous question. Jan 2025. Cathode ray tube shows us or demonstrate the properties of electrons. We have AC power supply, then with these electrons will be emitted from the heated filament and then they're being accelerated from the cathode to the anode. The question is asking, explain why electrons are released when there is a current in the filament. I should start my answer with the filament. And this filament is heated. And the reason because by the electric current passing through the small electric circuit or the shaded part here. For the second marks, I should say the electrons. The examiner said released. I should say are released now by the concept here we're using heat. I should say thermal, and we have electrons, we call them ionic, and release in physics we name it emission. I get 2 marks. In this section of the cathode ray tube, the electrons in the beam had de Broglie, which is the wavelength. Calculate the potential difference, which is voltage here, to accelerate the electrons. 4 marks. Firstly, I know the momentum, which is h over lambda, according to de Broglie formula. So momentum is h over lambda, 6.63, 10 minus 34, Planck's constant. Wavelength, 2.65, 10 powered by minus 11. Momentum now is 2.50, 10 minus 23 kilogram meter second minus 1 for momentum. There's one formula for unit 4, which is the kinetic energy equals p squared over 2m. So the momentum is squared 2.50 times 10 minus 23 squared divided by 2 times mass, which is 9.11 times 10 minus 31, the mass of electron. The answer is 3.44, 10 powered by minus 16 joule. Remember that the voltage equals the work done divided by the charge, or the kinetic energy here divided by the Q, which is the change in kinetic energy divided by the charge, and we give us the voltage. So the kinetic energy 3.44, 10 minus 16 divided by the charge, which is 1.6, 10 minus 19 coulomb. The correct answer, which is 2000 or 2100 volt. In this question we have a cyclotron, and the cyclotron made of 2Ds, and they're connected to alternating potential difference. So it's always a change in the polarity across the 2Ds. The most important thing is bear in your mind that we have a magnetic field which is always perpendicular to the Ds, so which is perpendicular to the path of charged particles or accelerated protons or electrons between the 2Ds. Here is the trick. How can I get 6 out of 6? Before answering the questions, you have to remember these keywords. There is a potential difference across the Ds. There is a gap between the Ds to allow the presence of the electric fields between the 2Ds. And there's a kind of acceleration and electrostatic force as well. Magnetic field which is perpendicular to the Ds, or the path or the velocity of the protons or accelerated protons. There is a circular path here, and there is an increase in the radius of the circular path, and there is a change in polarity across the Ds because there is a source of alternating potential difference across the Ds. Once the polarity changes, it means the charges or the particles or protons or whatever electrons inside the gap being accelerating in the same direction of the electric field lines. Once you know the keywords, let's go and attack the question. Firstly, we need to say that there is a PD, or there is an alternating potential difference, which is across their two Ds. And this potential difference will create an electric field. Where is the electric field? Let me say this is the positive terminal and the other one is negative terminal. Here we have the first D, which is on the left. It's a positively charged, and the other D, which is negatively charged. So the direction of the electric field, it goes from, or the electric field lines, they go from positive terminal to the negative terminal. So pushing the positively charged, or the protons, in the same direction from D1 to D2. Back to the answer, creates an electric field between the Ds. For the second point, once that we have electric field, which is simple by E equals to the force divided by the electric charge, which is the charge of a proton. So there is a kind of force here, which is Q times E. And as you know that we have a Newton's second law as well, and I'm dealing with a proton as a mass, so equals to mass times acceleration. The function of the electric field is to do what, or the electric force, to accelerate the protons where between the two Ds. Here is the something which is hidden. Once that you have a move in a charge, whatever proton or electron, this charge is accompanied by a magnetic field, and this magnetic field will interact with the external magnetic field, which is already perpendicular to the 2Ds, as highlighted before. Here is the concept. I should say the magnetic field, or the external magnetic field, they will interact with the magnetic field around the accelerated proton. And remember, there is an electromagnetic force which causes a kind of a centripetal force as well. I should say the magnetic field is perpendicular to the velocity of the proton, or I would say perpendicular to the path of the proton. And I would say, according to the formula, F equals Q, V, and B. F is a force, Q is the charge, V is the velocity, and B is the magnetic field. As a result, the protons, they would follow a circular path, and due to centripetal force, so F equals mv square over r equals q vb. I will cancel out one of the v with one of the square, so the radius of curvature of the circular path, or protons circular path, equals to mv over qb, which is momentum over the charge times the magnetic field. For the polarity of the D's, and this one switches every half cycle. Remember that frequency is 1 over t, over the time. Just to let you know, the polarity of the D's switches when, this is very important, while the protons are inside, or are in the D. Once the protons outside, the opposite side of what? The D is always oppositely charged to the protons. So the protons just keep accelerating repeatedly every time when the protons in the gap or between the D's. Oh, when you see this question, is not easy at all, and some of the students they are not able to get 6 out of 6. When you see this question, there are some few keywords. We have most and few and very few. These words very important if you are aiming for 6 out of 6. The examiner is asking to describe the observations from these experiments and the conclusion that were made from these observations. Definitely, it's Rutherford experiment, alpha particle source, lead box, and vacuum, movable detector, and thin metal foil. So I'm going to use my keywords. Most, I would say alpha particles, they went through. If I missed the word straight, thank you. Your name mentioned in the examiner report. You made a fatal mistake and definitely you get -1. Do not say went straight, through. You have to say went straight through. Most alpha particle were undeviated if you're not happy with the word went straight through. Undeviated. Once you give the examiner a kind of an observation, you have to say why. Why we have the alpha particles, most of alpha particles, they went straight through or undeviated because atom is mainly empty. Makes sense. The second keyword, which is few. Few alpha particles, they were deflected by small angles. Why? Because there is a concentration of a charge in the atom. So this is the reason the alpha particles, they are positively charged, and then we have a large amount of positive charges and they are accumulated at the center. We have a high concentration of the charges in the atom, and you cannot say nucleus because we didn't discover the nucleus at that time before this experiment. The last keyword, which is very few alpha particles, they had a deflection which is more than 90 degrees. They came straight back. Why? There is definitely a concentration of mass which is at the middle, but I cannot say at the nucleus. I cannot say that in the atom. In this case, I deserve 6 out of 6. Let me highlight the keyword most, straight, mainly empty for the atom, few alpha particle, deflected with a small angles, and concentration of the charge as a keyword. Very few is very important, and if you want to mention the reason for this one, or the evidence from the observation, which is 1 out of 8,000 particles. So every 8,000 we get like one being deflected back or came straight back with an angle more than 90 degrees, so had a deflection more than 90 because the concentration of the mass in the atom. 6 out of 6. In this question, many modern kitchens have an induction cooker, and the idea of induction here suggested more than a century ago. I don't care about this. The most important is look at the diagram and link it to a physics topic. He said iron kettle. Highlight the keyword iron, good conductor, heated, and alternating current through the coil. We have a coil. We have alternating current. You might think about the magnetic field. Oh wow, soft iron, easy to magnetize. The coil here and around the iron core. Where is the iron core? This one, the highlighted one. The examiner is asking for 6 marks. Oh wow. Explain, which I need a reason, which is an account of something with reasons. The kettle heats up, kind of energy dissipated, and when there is an alternating current through the coil or in the coil. Keywords before answering the questions. I should think about the diagram, how it's made of what. The diagram, there is an iron core, there is the two ends of the coil around the iron core. There is a power supply and alternating to change in polarity, maybe magnetic field, and there's one section here must be highlighted as well, the ionic kettle here, the lower part. I'm thinking about the induced electromotive force, and there is a current at the lower part here of the iron kettle. The most important thing is I'm not going to ignore the concept of having an electric current through the iron coil. Sorry, through the coil. We have, let me say this is positive and this is negative. The iron core is going to be magnetized. So let me say the magnetic field direction is going to be in red color, which is this is the magnetic field lines. If the direction of current, let me say like this, and it goes like that. So the magnetic field goes from the north pole, so this part is north and south. And because we mentioned that, or the examiner told us, there is an alternating electric current, it means there is a change in polarity. So you might say this is negative and this is positive. So the direction of the magnetic field is in the opposite direction. Okay. Step one, we have to say that there is a current. This one passes through the iron, through the coil, and produces a magnetic field. I get 1 mark. But remember, this also it's a not normal current. It's an alternating current. And this alternating current can produce an alternating magnetic field. I get 2 marks. There is one thing here is really important. If you think about the lower part of the iron kettle, the iron, it's a good conductor, and you keep changing the polarity of the magnetic fields due to their alternating AC or AC current. I learned in physics if we have movement plus magnetism, it will induce electricity. But here I don't have changing the coil, for example, to induce electromotive force. But the point is, if you keep fluctuating or changing the direction of the magnetic field, like for example N to S from, for example, according to these arrows, and the magnetic field or alternating magnetic field, they interact with the electrons or the free electrons in the lower part of the iron kettle. These naughty electrons, they will become more freely, and there is a kind of an induced electric current because the lines of the magnetic flux from the iron core and the coil will they being cut by the kettle or the cut by the kettle. I would say the magnetic field lines or magnetic flux or lines of magnetic flux cut by the kettle or the core. As a result, there is EMF is induced where across the kettle. Now, like there is an induced EMF, which is voltage across the kettle. In this case, if we think about EMF as voltage, or it's measured in volts, and it's there is a current times the resistance of the kettle, according to this simple equation, there is an induced currents. It's not only once; they keep circulating in the kettle. If we think about this one microscopically, we have like kind of a free electrons now at the lower part or in the kettle being induced. The movement of the electrons can increase the temperature of the kettle. The kettle now heats as energy is dissipated by the heating effect of currents. I might say the core heats as energy is dissipated and thermal energy is transferred to the kettle by conduction. 6 out of 6 in this question. The examiner underlined one keyword which is really important. There is a kind of an induced, sorry, there is an induced EMF across the kettle. He underlined this keyword, induced EMF. For this question, the cyclotron, again, explain how the cyclotron it produces a beam of high energy particles. You should refer to alternating potential difference and magnetic field. The structure of the cyclotron, the 2Ds, high speed particles beam, AC power supply, always a change in the polarity. Here's one time positive, the other one is negative, and the source of a charged particle, whatever electron or protons, it depends on the particles. So to get 4 out of 4, I should mention the electric field. And the electric field, which is E equals F divided by Q, or the force equals the QE. And remember, according to the Newton's second law of motion, which is mass times acceleration, I should change my words into, or the symbols into, or the equations into words. This electric field, or the potential difference as well, which is across the 2Ds, I would say across the 2Ds, I will get 1 mark, or I would say the electric field which is between the Ds here, which is 1 mark. What happened to this electric field? This electric field can accelerate. This is the keyword according to Newton's second law, which is accelerate the particles, or I would say the charged particles. I think I deserve 1 mark. Remember the magnetic field. This is magnetic field, which is an external magnetic field or magnetic force. And if there is F equals Q, V, and B, and if you are a further math student and you understand cross product in math, so you are able to understand what I'm saying. If you change the formula to F equals Q bracket V cross B, it means if we have three or the two vector quantities, the velocity and magnetic field, or whatever the strength of the magnetic field, so they are two vector quantities. They make the angle between them, which is 90 degree, or they are perpendicular to each other. So the induced electromagnetic force, which is must be a vector quantity, and also as the product here of the cross product, it is also perpendicular to the path or velocity and the external magnetic field as well. So this magnetic field or magnetic force, it's at right angles to particles path, or you might say the velocity of the charged particle. There is one thing you have to know: F equals a QVB, which is equal to mv square over r, and the radius of curvature, if you cross multiplicate as we did before, so it's mv over qb, which is momentum over qb. So the radius of curvature we have to think, or the radius of the circular path. There's an induced electromagnetic force could you please write in capital EMF on the charged particle is this force, this induced electromagnetic force on the charged particles. This one, it's maintaining or maintains the circular motion. And please write the equation as an evidence. This particle experiences a centripetal force. I would say it's a centripetal force. The examiner, now I have a quick look. I already mentioned the magnetic field and potential difference, but I made a mistake. What? I forget to say it's an alternating potential difference. What does it mean? What's meant by alternating potential difference? For the word AC as a power supply, the power supply always, there is a time taken which is 1 over F, the period equals 1 over frequency. So there is a switches the polarity every half cycle. So if you want to make it clear or more clearly is polarity of these switches every half cycle. Or when or you might say the potential difference or alternating potential difference polarity changes or switches when the particles is in the D. Then the AC power supply has a constant alternating frequency. It means there is a constant time or period, and the period is independent of the speed of particles, and the time is independent of the speed of particles. Could you focus on the last point? What does it mean? Because some students, they cannot understand which is going on here. Let me explain the concept. Time is equal to distance over speed. Distance, which is the circumference of the circular path, which is 2 pi r, divided by the speed, which is v. I know the radius, which is radius of curvature, is mass times the velocity divided by qb. It is momentum over qb. Substitute the radius in the formula of the time. Time equals 2 pi over v times the radius here, which is mass velocity over qb. We notice that we have velocity in the denominator cancel out with the velocity in the numerator. It's a 2 pi m over qb. It means the time taken now. The time taken now depends on what? Time taken, or the period, depends on the 2 pi, which is constant, and the mass of the electric charge, whatever proton or electron, which is always constant per the charge, and the q, which is the charge of the particles, which is in coulomb, constant, and b, which is the value of the external magnetic field. And this also, it depends if you change the value during the experiment, but definitely it's always constant. The time taken now, it's constant and is independent of the speed of particles. Here we get 6 out of 6. Sorry, it's 4 out of 4 in this question. In this section is not easy question as well. This is LINAC, linear accelerator. We have power supply here, which is always, as we said before, changing polarity, positive, negative, negative, positive. Here we have electrons, which is negatively charged and is going to be accelerating or accelerated in between the charging or charged drifting tube. And the examiner is asking to explain, which is an account of something with reasons, how LINAC produces high energetic electrons. And the examiner give a kind of guidance to, you should refer to the AC power supply and the length of the drifting tube. Why we have increase in length, maybe because here the drifting tube was small, they're slightly larger, so and larger and larger. Increase in length is really important. When before answering the questions, I have to think about there's some keywords like electrons as a charged particles, accelerators or acceleration, electric field, where exactly, and the change in the polarity is really important. Do we have a constant frequency or not? Period is important. The length of the drifting tube, that increasing or same. And I have to know why, when the energy increases, why I'm applying which formula. Do you think that we have that I'm dealing with the relativistic electrons, or they might reach the speed of light or close to the speed of light? What do you think? And maybe later, if the end section here, he give us the end section, the length of the tube same, what does it mean in physics? These are important keywords. Let's go, and we're going to attack the question and try to get 6 out of 6. Firstly, we have electrons, and these electrons are accelerated. Again, if you think about the charge, and we have there's a kind of acceleration and the electric field, so I would say by an electric and field, and this electric field definitely between the drifting tube or the drift tubes. According to what and where in the diagram, I can use the diagram. Just say, let me say, if the electron here, this is negatively charged and this one is positively charged, so the direction of the electric field from positive to negative, but the electron itself being accelerating in the opposite direction of the direction of the electric field. There is no issue for that, by the way. It's just a repulsive electric force from the first drifting tube and attraction electrostatic force from the second drifting tube, and still we have to use F equals QE, or E equals electrostatic force, which is divided by the charge of the electron. I would say, according to the formula to support my answer, which is A equals F divided by M and QE over M. I know that the electric field between the drift tube is directly proportional to the acceleration. This is point 1. I get 1 mark. For the second point here, which is, do we have a change in polarity? AC. AC, which is the power supply, the polarity always changes. And once the polarity changes, where? When the electrons are in the tubes. Like the electrons before, they were in the D's of the cyclotron. That I have to say what. So the electrons or the electric field is always in the same direction. So the electric field in the same direction all the time. When the particles were in the gaps. I'm going to go back to the diagram just to explain this concept in detail. Let me say the electron is here, and the electron might be here as well. The direction of the electric field labeled by the red. This is positive, this is negative, this is positive and negative. The direction of the electric field from positive to negative, from positive to negative. It means across the whole journey of the accelerated or accelerating electron, this direction of the electric field, once the electron is in the gap, it's also always in the same direction from positive to negative. But if the electron not in the gap, so there is a change in the direction of the electric field. But once the electron is going to leave the gap and leave the drifting tube and is going to be in the gap between the drifting tube, here we always keep bear in mind the direction. For the third point, we have the AC, the alternating frequency, which is also is constant. And this frequency, according to the formula, F equals 1 over T. And for the indicative point 4, the length of the drifting tube. length of the drift tubes increases, so the electrons spend the same time in the tubes. And this one according to if distance s equals velocity times time. So the length increases, so the velocity increases because the time taken is constant. And finally, if the tubes have the same length at the end, what does it mean? It means as the electrons as an accelerated charges, they approach the kind of a maximum speed, but not the speed of light. Because if you think about s equals v times t, think about the formula s equals v times t. If the time is already constant from the formula 1 over f, and the velocity and the length now, so velocity here cannot increase because the length of the drifting tube is at the end is constant. So we have a time taken constant and length is constant, no more increase in the speed. And here we have very high speed, and we try to approach the speed of light, but you cannot reach the speed of light, which is 300 million meters per second.